Well, this is journal page 106, lesson 5.5, dealing with slope. And number one, it says find the slope of the line. So number one, remember that slope equals rise over run, which is the change in y. Remember, the triangle means the change in the y. And remember, the y-axis is our vertical axis. So our change in y is how much this has gone up, or the rise. And then the change in x is how much it's gone over here, because the x-axis is here. That's the run. So how much did it go up? Over. How much did it go over? All right, so number one, we start at 0, 0, and we go up to 2, 4. Since they gave us the graph, we can actually just count. How many did this go up? It went up 1, 2, 3, 4. From this point up to where this point is, it's gone up 4. So for number one, our rise would be 4. And starting at this first point again, it went over 1, 2. So it went up 4 and over 2, or 4 over 2. This can be simplified to a slope of 2. Number 2. Here, they start us at this point right here. We go up to this point right here. It went up 1, 2, 3. So our rise is 3, and our run is 1, 2, 3, also 3. So rise over run is 3 over 3, which simplifies to 1. And number 3. Now we've got a point way down here, a point way up here. So let's look for our rise. When I'm doing counting how many it goes up, I do always have to make sure that our lines are going up by 1 and going over by 1. And we will have a couple that try to fool us either in the book or on a homework, not on a quiz. But so make sure you're watching the interval of these lines. All right, starting down here, it goes up 1, 2, 3, 4, 5. It went up 5, so our rise is 5. And our run is 1, 2, 3, 4. It went over 4. Our slope is 5 over 4. Do not make that a mixed number. I don't want to see 1 and 1/4. Just make it 5 over 4, just like it is. Number 4. Graph the data, then find and interpret the slope of the line through the point. So we have to graph it. So hopefully you still have those graphs that I passed out in class. They should look something like this. And here we go. Our X is minutes, so we'll write that down here, minutes. Our Y is pages, so pages over here. And the first point they give us is 0, 0. So I like to put the points over here, 0, 0. That's right here. And now we have to figure out how much are these going to go up by and up by and over by. We'll just go by ones on this one, so each line will be worth 1. We might label a couple of them, 1, 2, 3, 4. That would be 5, 6, 7, 8, 9, and 10. And same thing going up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, next point would be 1.5. Which means I go over 1 and I went up. The y is 1.5, so 1.5 or 1.5. The next one is 3, 4.5, so 1, 2, 3, 1, 2, 3, 4.5. And finally, 5, so over 5, and then up 7.5. 1, 2, 3, 4, 5, 6, 7, and 0.5. Oops, I didn't write those. 3, 4.5, 5, 7.5. Okay, there's my 4 points. I like to use a nice straight edge here, like everybody should. Let's see. 1 and 1.5. 3, 1, 2, 3, and 1, 2, 3, 4.5. And then 5, 6, 7.5, yeah. There's our line. Then find and interpret the slope of the line through the points. Well, we could put a lot of different things. We could put, because it goes through the origin, we can choose any of these points, and we put the y value over the x value. So I could say the slope is 7.5 pages per 5 minutes. I could say the slope is 4.5 pages per 3 minutes. But the best one would be the slope is 1.5 pages per 1 minute, because that's our unit rate. So it says find and interpret the slope through the points. The slope, I'm going to put 1.5. Well, we'll put that back on our lined paper. So for number 4, slope equals, and we said it was 1.5 over 1, and that's 1.5 pages, because that's our y. Remember, change in y is on top. So we look at our y-axis label here, units, and then on the bottom, it's 1 minute. So 1.5 pages per 1 minute. When we put those units on there, that is interpreting the slope. Number 5, oh man, they gave us a graph right down there. Are you kidding me? I wasn't looking at that at all. And I graphed it on this one. So you didn't have to have this graph paper. I like to do it on a slightly bigger one, but you could have graphed it right down there. Number 5, same kind of thing, miles and calories. Miles is our X unit, so I'll put miles down here. Calories over here. 0, 0 goes right here, obviously. And now I've got 1, 135, 2, 270, 3, 405. Well, the 1, 2, 3 is easy enough to go along the bottom. 1, 2, 3, 4. We can just go by ones. But what am I supposed to go up by here in order to get these? I could go up by 135s, and that could be my interval. If I do that, my graph's going to be really just right down here. So what I'm going to do, and you could do it how you want to, but I'm going to go 0, then I'm going to skip 1 and put 1, skip 1 and put 2, skip 1 and put 3, because that's as far as I have to go for this. I am going to skip 1 and put 4 just because. And here I am going to use these 135s, but I'm going to skip 1 up, going up as well. Skip 1 and make this 135. Skip 1 and make this 270. And skip 1 and make this one 405. And I labeled it inside because my word is right there. Well, now I can graph these. I got 0, 0, 1, 135, 2, 270, 3, 405. And I can put this in here. And now, when I'm looking for my slope, I have to be careful. Because, remember, slope is rise over run. Slope equals rise over run. And what some people will do is they'll say, well, look, it went up 2, 1, 2, just counting these lines. And it did go up 2 lines, but remember, to get to that second line, that's 135. That's way different than going over 2, which that's just getting to 1 instead of doesn't. These aren't the same intervals. It's going up by 135 and over by 1. So make sure that we're counting. It goes up 135 and over 1. So 135 calories for 1 mile is our interpreted slope. By law, the maximum slope of a wheelchair ramp is 1 to 12, 1 foot to 12 feet, or notice it doesn't have any units here, so this could be 1 inch to 12 inches, 1 mile to 12 miles, although that's quite a big wheelchair ramp, 1 yard to 12 yards. It doesn't matter, that slope's going to be the same, 1 unit per 12 units. It goes up 1 and over 12, whatever you're talking about. A ramp is designed that is 4 feet high and has a horizontal length of 50 feet. Does this ramp meet the law? Well, let's look. So 6A. It needs to be a maximum slope of 1 to 12. Okay, that's as steep as this thing can be. It can only go up 1 foot if it goes 12 feet long, so that it's nice and shallow, because you don't want somebody at the top on a wheelchair coming down a very steep slope. So you want it nice and shallow. What you wouldn't want is like, hey, let's go to a double black diamond on your wheelchair, and whoa, okay, well, that's not going to be good. So shallow slope, it can only go up 1 foot if it goes over 12 feet. So here, it's going up 4 feet. Well, if it's going to go up 4 feet, 1 to 12 would be the same as 4 over what? How far does this thing have to go to be legal? Well, I multiplied by 4 on the top, I multiplied by 4 on the bottom. X has to equal 48. 48, well, ours is 50, which means it actually went longer than it had to, which would make this shallower than it has to be, less of a slope. So 1 over 12 is greater than 4 over 50. So that would mean that this is legal. Yes, it meets the law. And why? Because 4 over 50 is shallower than 1 over 12. It's safer than it needed to be. And part B, what could be adjusted on an unacceptable ramp so that it meets the law? So let's say we have a ramp that is unacceptable. For instance, here's a ramp that would be unacceptable. What could we do? Well, one thing we could do is we could lower the height. Although the height isn't usually too adjustable. We have the ramp because we're trying to get up to something. We can't just lower everything. So what we can do is we can lengthen the ramp. So in order for what could be adjusted on an unacceptable ramp so that it meets the law, you have to lengthen the, and we'll call it the run. Remember how far it goes over? The run of the ramp. The rise usually is pretty fixed, but the run is what we can do. So we could just draw it out longer and longer and longer and longer. Cool. Sometimes you probably go to a ramp somewhere and it goes up and then you stop and then it goes up again so you can get to wherever you were going. And that's because they needed it to be long, but they ran out of room. So they just wrapped it around to make that slope shallower. They lengthened their ramp without using too much space. Well, I hope you had an easy time getting this, although if you have any questions, please make sure you ask them. See ya.